The old tools are good tools, and we will not make better ones without understanding what made them good. I'm Ray Myers, retrofuturist software mender at your service, and welcome to Craft versus Cruft. So today I've got a talk for you I've had kicking around called Java is pretty good, actually. That's almost a hot take. For the entire time I've used Java, starting 15 years ago, Java has been kind of a favorite language to hate on. It's ugly, corporate, mediocre, what have you. It used to be that they would call it slow, and now it's one of the faster languages that you're going to see, but there's always something wrong with Java. When I originally had the idea for this talk, it was for people who are already experienced in other languages that were going to be maintaining some Java and maybe were a little bit nervous about this because of the reputation. So I wanted to take the other side, though a lot of the criticisms of Java may be justified. Let's hear the other side of the coin here. And generally on Craft versus Craft, I don't get into talking about specific tools. And this is a bit of an exception, but there are broader points that I'm trying to make here. And I thought that this would be a good counterbalance to a lot of the more recent material I've had, which is, relating to artificial intelligence, a little more speculative, a little more new kinds of things. This channel is really meant to be about general principles, about fundamental guidance. So this is getting back to form a little bit on that. Hope it resonates. But if you would like to follow along with the newer speculative stuff, I do have some new articles on Mender.ai that I'll link in the description. You can look at. Let me know what you'd like to hear about next. Subscribe if you're so inclined. Let's get into this. Some things I'm going to get into here. What are the advantages of Java? What are some things, if you're coming from another language, that would be helpful for you to understand about the project structure of a Java application? I'm also going to talk a little bit about read-by refactoring, even though that's not specific to Java. I recommend you do that wherever you are, but because of the tool support in Java, it does become particularly easy there, and it's a good place to be learning that strategy. We'll talk a little bit about the Java ecosystem, some other languages that are available in the JVM, and we'll learn more to cover a bunch of angles that I will not. So some of those things that aren't covered is, and these will all be links, a language tutorial. We're not going to go through a ground-up language tutorial. We're not going to try to assemble all of the best practices. We might touch on a couple. That's not really the focus here. We're not going to cover, though I think this is a very interesting area, the general approach to learning a new language when you already know some. Chelsea Troy's got a great article on that. I do have processes that I use for that. And, whatever. There's an infinite number of things I'm not going to talk about. But why should you use Java? If I'm going to, for the moment, be the Java advocate, the old Java versus Ruby feud, which has cooled down a little bit over the years, is a good example of why I think you should. Sid, the GitLab CEO, said at one point, and oddly enough is saying this in the context of kind of advocating for Ruby, of saying why Ruby was a good choice, but with some caveats, because they did a lot of work with Ruby, saying Ruby was optimized for the developer, not for running it in production. I say production is reality. I say, how could not being optimized for running in production, how could that not be a deal breaker? We have built the world economy on software. What we desperately need is for our systems to be maintainable, to be predictable, and that's okay if it costs us some semicolon here and there, an extra keyword here and there. Like, you're really missing the forest for the trees if, a lot of the complaints that you see about Java center around there's a little bit of superfluous syntax. And then what they're suggesting instead is something that you're going to say, this wasn't optimized to run in production. come on. Like, if we're going to make the world better, like, let's not make it much worse in the process, right? Though GitLab is a great product. I enjoy it, regardless of what languages they may or may not be currently using. I'm not even familiar, but it's a good product. Really, though, the main reason why you should use Java is because you already are. Like, you usually are not even in a position to pick the language that a project is going to be in. For the most part, most of the work is in maintaining something, adding to it, evolving it, and we already have these choices. Sometimes we change some of them. Sometimes we introduce a new choice, but mostly we are just sort of managing the collection of choices we've inherited. So I'm not even telling you to choose Java or not to. I'm telling you, if you have already had Java chosen for you, then all is not lost. This is actually not a bad space to be in. To get a little bit of what they were going for, at least with it, because at least they did have a pretty consistent philosophy coming in. James Gosling, who created Java, said this in 1997 in a famous talk called The Feel of Java. Java is a blue-collar language. It's not PhD thesis material, but a language for a job. It feels very familiar to many different programmers because we prefer tried and tested things. Now, as a language designer, this is kind of the mentality you want people to have. You don't want them throwing in the kitchen sink, because over time, people's use of the language diverges. You get these different sub-factions that are like, these are the features we use, and these are the features we use, and now our code has trouble calling each other. The more features you add, the complexity grows not linearly, but greater than that, combinatorially, with the ways that the features can be combined together. So while Java has maybe overshot the mark in how conservatively we should grow, how few features we should have, you do want to be a little bit on the more conservative side of that, relative to how quickly that libraries and things can evolve. So this was a good idea, in my opinion. They're striving to be safe, simple, boring. However, they have changed quite a bit. It's been 26 years. The biggest changes I would observe are in Java 5, they added generics. So lists, for example, collections could be declared of specific types and not just of object. I think it's a good change, but when you've got a code bases before and code bases after that both, this introduces a lot of confusion, and it had to be added in a backwards compatible way. 10 years later in Java 8, they added the one I'd been waiting for, lambdas, anonymous function objects, lexical closures, whatever you want to call them. A couple years later, they added modules, which was a big change depending on your point of view. I haven't been impacted by it a lot, but it changed the way that the projects were built and had a lot of ecosystem impact. Every time you add a new way, you now carry the baggage of not just that, but the old way still being supported, the inconsistency. So over time, programming languages get stale, whether they evolve or whether they don't. Comparing it to another of the top used languages, which have recently overtaken it in a lot of indexes, Python. Java and Python, they're both mature, both very old. They're both production grade languages, and they've emphasized the same conservative approach, add not too much at once, and they have very large, stable library ecosystems you can use and build on. It's generally been the case that Java's been more on the performance, safe, running, optimized for production stage, and Python is a little bit more optimizing for developer convenience. But there are ways that you can get more safe in Python. There are ways that you can get more convenient in Java. I have a video on polyglots and why I believe it's good to be a polyglot dev, but it's not necessarily good to be a polyglot team. That can mean some unhealthy things. I'll just say, if you want to consider yourself a polyglot programmer, that means you should meet the problem where it is, instead of trying to inflict your history and preferences onto the ecosystem you're maintaining. Number one complaint you hear about Java, I think, is that hello world's long. Okay, whatever. I don't need to write Hello World very often, but you know, just just those first few moments of starting a new program, yeah, you got a lot of noise. You know, you got a lot of concepts being introduced just to write print hello world. Look, we're declaring a package, we're declaring a class, we're declaring that it's public. We've got like a static method here. We're accommodating some arguments we don't even need. Instead of writing print, we're, reaching into like the system namespace, and yeah, lots going on. But I say to you, I don't care. I don't care how long it takes to write Hello World. I care how well I can maintain an app. And so that's just not a good heuristic. But also, I can write Hello World a lot quicker than this. This is not how Hello World is spelled in Java in the real world. Like, Hello World is spelled Clover N for new Java class. And then I type the name of the class. And then instead of typing public static void main, I type psvm tab, and then it fills in this main method for me. And then instead of system.out.println, I type sout tab, and it writes that for me. And then I type my hello world. So, what's the big deal? It's really easy to write hello world in Java. It takes the same number of characters. Just use IntelliJ like a normal person. So, again, like, want to make an app? Well, the good news is there's very simple conventions that tell you where you ought to put things in the folder structure. We don't have to argue about that. It's all very predictable. If you have a package of a certain name, we know exactly what folder it's going to be. That said, some would say it's also a lot of overhead to go through to create these folders. So on a Bash terminal, I can create the folder structure in a couple commands there. And I can make this Hello World file in the appropriate directory, and then I can run it with my javac commands and so forth. Again, this isn't really how you do it in the real world. This shows you where all the files end up going and stuff. But I would suggest you would probably just use Gradle init, and you'd say, hey, I'm running a Java application, make my stuff, and then you would get a functioning app that you could start, developing with. So, fine. You want to write something bigger? You want to write like a Spring web app? Then, you go into Spring Initializer, and you can create something that's got things wired up the right way, and then you can develop from there. If you don't like Spring, a lot of people like Drop Wizard. You could try that. So again, with the objection that Java doesn't optimize for the beginning of new projects very well, that it's hard to just, get into main and start typing things. First of all, that's not a very important concern relative to the ease of maintenance over time. But also, we've got tools that make that just fine. So you want to get started writing some Java, I suggest using either IntelliJ or IntelliJ. Those are your three options. In build tools, we like Gradle, we like Maven. I personally will use the Groovy DSL in Gradle still. There's also a Kotlin DSL. And this is the folder structure that you're gonna see. Source main Java, test in source test Java. There's also source main resources for other types of files that might be needed. And within that, there's package subdirectories where the dots in the package name just become slashes. We package Java projects typically in jars and wars unless we're going to make a command line app zip. The top level constructs to be worried about are generally classes and interfaces. The entry points are main methods within a class, like you saw earlier, and we unit test with JUnit. Some more on packaging. When we make those jars and wars, that stands for Java Archive or Web Archive, and those are simply zip files that include compiled .class files. A .java file, which usually has one class in it, will tend to compile into one .class file. As I say, those all go into this zip called a jar. Usually, jars do not include library dependencies. Those would be in other jars. Wars typically do include library dependencies. You can also make what's called fat jars that include the other jars within them. We used to take these wars and deploy them to freestanding web servers that were already running, like Tomcat, like WebLogic, like WebSphere. It is increasingly common now to either ship a fat jar that contains its dependencies and contains an embedded web server within it, so you can just run it directly, or to ship Docker containers. If you're shipping a command line app, I recommend using the Gradle application plugin. It's awesome. Anyway, read by refactoring. This is really cool. If you're getting into a legacy system, which is, according to me and Arlo, any system in production, then read by refactoring is a good way to start understanding the code a little bit at a time. You just don't need to understand it all, but as soon as you have one bit of insight, you can capture that directly into the code by changing or introducing a name. In Java, you have IDE support through IntelliJ, through other competitors that you should just use IntelliJ instead of. And so these kinds of incremental refactoring can be very fast and very safe using those features. But you might be saying, hey, this is legacy code. Not all of it has tests. Well, you can also use these safe refactoring steps to make untestable code testable fairly quickly, reduce the risk profile of that. So I want to show you a little bit about how read by refactoring actually looks. So this is an email sender example that was introduced in a talk by Michael Feathers. Emily Bache has gotten the code and put it online along with a bunch of katas she's got up. And here is a time-lapse video of me in 25 minutes doing a lot of refactoring on this code, right? But I am not actually doing any of the direct editing myself. All of the actions that I'm taking here are done by the IDE. I'm selecting a block. I'm saying I'd like to extract this method. It looks like this is a block of something, or I'm doing a rename, or I'm introducing a class, like lots of different actions here. But over the course of this 25 minutes, and you don't need to follow every little thing that's happening here, but I've taken this from one main method that's 170 lines long to 3 classes, 15 methods. The longest of those methods is only 30 lines. And again, I am doing this without any direct edits to code. Every single action here is done by the IDE with just me selecting from a menu, entering a name, things of that nature. So this is incredibly powerful. It works very well in Java. That's not the only language you can use it for. I think it's just a matter of how much energy has been put into the tool support. Something else I want to briefly cover here is dependency injection, which you will see in a lot of languages, but you'll definitely see it a lot in the Java ecosystem, and it may be difficult to understand like what the purpose of it is. I find dependency injection easier to think about independent of a framework, independent of a DI container doing this magic behind the scenes. I don't think you need that part. I think the important part is inversion of control. So this is an example where we're injecting collaborators. There are other places you can inject other than in the constructor, but I find in the constructor is the most commonly best place. So this service has something that creates messages and then something that sends messages, and then it's going to use some logic to determine how they should be used together. Well, if the instances of message factory and message sender are passed in, then this code is now very easy to test and very easy to run with different implementations. They maybe send the message over different means, like one of them sends a text and one of them sends an email or what have you. But for testability is one big reason this gets used. This is one of the ways that tests exert design pressure over your app by needing to use your code in multiple contexts. It has forced you to make your code more flexible, in this case by allowing the inversion of control here. Something you're also going to see used, and perhaps you could say overused sometimes, is interfaces. As you see, I've renamed forward service to forward service impl and extracted an interface called simply forward service, which is now what clients of this code should depend on where possible. Just depend on the interface, and I'll be able to provide multiple different implementations of it. Another common pattern you'd see there is maybe not putting impl on the end of forward service here, and instead making the interface named iForward service. Whatever, argue about it if you like. Just stick to one convention within a code base. It'll often be the case that the only implementations of an interface, at least for a very long time, will be the implementation used in the prod code, and then some test double that is used to test clients that use this code. I prefer this over using so-called automock frameworks. And GPA-Hill's got some great explanations as to why automocks tends to create more problems than it solves. But Mockito is probably the most popular automock library in Java. I would prefer to use plain text double code. If you're on the JVM, you're not limited to Java, of course. You've got a number of other languages that often have very good integration with Java, so you might be able to just partially introduce them. The one gaining the most momentum right now might be Kotlin. Groovy for build DSLs and things like that. DSL is domain-specific language, by the way. Has got some momentum, but as a general purpose language, I think it's fallen out of favor. Closure is a really interesting Lisp dialect. Then you have Scala, which has been the first on the JVM to have a lot of really interesting features, but also has drawn a bit of criticism for maybe adding too many features, allowing too many ways that it can be used. Kind of the opposite philosophy of what I was talking about at the beginning. And if you want to see what the other extreme looks like, Scala is where you want to look, I guess. As of 2021, Java was looking still pretty strong in the market share with 91% of projects. A lot of projects that use these other languages use Java as well. That's why this doesn't add up to 100%. But you can see the second most popular is Kotlin. So that would be maybe the first to look at if you want an alternative. But as someone who used pre-Lambda Java and felt very confined by that, I've got to admit, since work began on Scala and all the other languages eventually that we just talked about, Java has added a ton of important features. They've added lambdas, they've added streams. These two things allowed working with collections in a way that was not perfect, but much easier than it was before. Added resource management blocks. There's a lot more type inference that there was. Record types are an absolutely huge improvement. Do you really need other JVM languages when Java has added so much? I mean, maybe your answer is yes, maybe the answer is no. But for me, it does shift the scales of comparison with at least within the JVM languages, especially when you consider how much better the tool support and the ecosystem and other things are. So if I didn't cover exactly the points that you were looking to learn about in this, feel free to leave a comment. Let me know. I might make a video on what you suggest. But I also recommend checking out Effective Java 3rd edition by Joshua Bloch, Growing Object-Oriented Software Guided by Tests, anything on Tech Debt and Refactoring by Martin Fowler, Arlo Belshi, Chelsea Troy, and I'll leave a bunch of other links in the description, and you can see what suits you. Thank you very much for watching, and as Lao Tzu said in the Tao Te Ching, with patience, the most tangled cord may be undone. Thank you.